G'day there, my name's Angus and I'm looking at multi-species cover crops in paddocks versus ryegrass monoculture paddocks and the food webs of them and the consequences of having monocultures on farming land. So here we go, we've got the surveyed area here. As you can see down the bottom in the yellow, this paddock has since been laser graded since this satellite image was taken, but there's now a multi-species crop in here consisting of many ryegrasses, many legumes, brassicas such as the purple top turnip. We've got a bit of linseed, lucerne, chicory in there, a few perennials such as plantain, and up at the top there's a pink. It's not very far away from this other crop, but that's the ryegrass. And so you can sort of get the proximity of the whole trial area. These being so close together could actually affect what sort of prey animals we're seeing, and could be quite similar, but I'm sure we can sort of see a difference in the soils between these two. So let's have a look at that now. Here you can see the multi-species food web. Down the bottom here in this first taxon level, you see the diverse range of grasses and plants that we have growing on this paddock, which are feeding the fungi, bacteria, nematodes and protozoa. There's quite a diverse range there, allowing more insects to gather and improving the upper levels of the taxon, upper taxon levels. Here though you can see in the ryegrass only paddock, it's a lot less down the bottom of the taxon levels there, only bacteria, and some nematodes remain, so that reduces the amount of feed for the upper levels such as the insects and the miniature birds, the amount of energy that can leak into those taxon levels, and therefore less of them can exist when there's a monoculture of ryegrass. Here, moving on to survey methods here, when we're surveying the soil biology, can be identified using metabarcoding of environmental DNA, which in a single soil sample can identify thousands of species of nematode, protozoa, fungi and bacteria, resulting in a much quicker survey than using a microscope and trying to single-handedly identify each of these species. Sticky traps are used to identify small flying bacteria, and beating a sheet analysis can identify insects on the plant by shaking the plant and they're getting the insects off onto a sheet, which would then count the insects afterwards, taking note that we must be careful of the weather and ensuring that this analysis is done along a transect line to ensure random and effective analysis in the paddock. Smaller mammals, it's good to identify them with a motion camera because they're often hide when humans are actually around. But you can also detect them if you're experienced enough by identifying scats. It can be kind of hard to identify certain mouse scats between rats or whatever. So obviously you've got to look at that sort of thing. And then for birds, especially prey birds, visual and audio analysis identifies them quite effectively. Here we go, moving on to ecological consequences. There's a reduction in plant biodiversity, obviously, if we're spraying the paddock out and only planting a monoculture of ryegrass. So that affects the soil biodiversity significantly, reduces the fungi, all sorts of nematodes and protozoa, and some bacteria as well. So there's less feed, therefore, for the insects and consequently for wildlife such as birds and mammals. Biodiversity also increases plant production. So in the crop we see much higher yield of an overall of the crop. But interestingly, each individual species is probably a bit lower. So if you're comparing the ryegrass in the paddock compared to the ryegrass in the crop, the actual ryegrass in the crop is quite a lot lower. And therefore you could say it's sort of affecting the individual species, but as a whole, the crop has a much larger biomass. What's more, the reduced farm resilience, when biodiversity is lost, there's less farm resilience. So you're more susceptible to extremities in the weather, such as floods and droughts. And biodiversity can improve farm resilience. So farmers should be looking at how they can improve their biodiversity, become more proactive to these extremities and fluctuations in weather, and allowing them to be less stressful and more prepared. And also, if there's less biodiversity, there's less profit, because these big weather events are taking a lot of time and energy and money, resources, into fixing the farm back up afterwards. So if they're more resilient, there's more profit. Here's the references. Quite interesting to have a look through these if you have the time. Probably won't if since you're marking, but thank you.